All right. This talk's a little different than most of the ones I've been seeing. This is about planning, assessment and planning. How many people here have some kind of a role in planning? All right, well, quite a few. Great. So I'm going to go ahead and get into the concepts here, but I just want to acknowledge my co-authors, especially Samantha, who is our intern funded by NOAA, did an amazing job, learned a whole bunch of tools on her own with very little support, and actually created a tool, so she did a bang-up job on this. So let me just talk about first where we did the work that I'm going to present. So this area of focus is in it's called the Northeast Ecological Corridor of Puerto Rico. So if you know Puerto Rico, this is the eastern side. Fajardo is over there, Culebra, Vieques. And so it's this outer green boundary here that corresponds to the study area where NOAA was using a lot of its cool new toys, doing a lot of really great mapping, gave us a terrific corals map, for example, to work with. And then we came on primarily to deal with land-based stressors, which wasn't in the project budget. So they gave us a little bit of funding for Samantha. And then we also wanted to demonstrate the whole concept of this Integrated Land-Sea Planning Toolkit. So I will just point out that we've also done this kind of work in several other places on all the US coasts in the 48 states. So let me talk about key components of integrated land-sea planning. So one is that you're addressing resource management needs across realms. When I say realms, I mean terrestrial, freshwater, and marine. Also that we're addressing stressors within and across those realms, and ideally in both directions. And so we're talking about direct uses and stressors in the water as well as on the land. The land-based stressors, we're primarily thinking about sediment and nutrient pollution flowing off the land that can affect those aquatic resources. And then sea level rise and storm surge, which can move the other direction and impact our land-based resources. And then we're going to integrate cross-realm ecosystem processes, so that's our sediment and nutrient delivery, as well as then there's the human side, integrating the agencies and their policies and the stakeholders that are interested typically in those different realms, but we need to connect them up as well. And so a key aspect of this is revealing the co-benefits as well as the trade-offs by doing this kind of work. And I just give a typical example there of US, not in a conscious policy way, but has basically decided we're going to sacrifice productivity in the Gulf for more corn in the Midwest. All right, I'm going to go through this box by box. I'm just kidding. But this is our framework. I've never seen it so big. This is great. I feel like I'm doing a TED Talk up here. So, but basically, we have our stakeholder processes here. And this turquoise color is primarily things that our stakeholders are really in charge of. There's these gray boxes that are primarily the technical team sort of stuff because we're gray and we're boring. And then there are these kind of dark turquoise, which are more of a mixed thing. Obviously, everybody's having some influence on every aspect of this, but the idea is it's a collaborative process. Even though Samantha ran all these tools, normally we're going to think of it as a big collaborative process here. And so if you look through this, primarily this is a fairly typical ecosystem-based assessment and planning approach. But a key thing here, this little circle, the cross-realm process models, that's really what links up these realms and makes this an integrated land-sea planning process. So we attach a toolkit to this, and normally, people see toolkit, they might have been thinking one tool with various sub-tools in it. We don't believe in the super tool approach. We really believe in going with the best tool for the job, and not to pick on anybody in particular, but Marxan is a terrific tool, but people use it as the screwdriver, the saw, the hammer. It's overused. It plays a really important role, but what we have here is the idea of a common database our NatureServe Vista ArcGIS extension, and I won't take the time to read through all of that, but it plays a lot of key roles in assessment, planning, and then ongoing adaptive management. I'll walk through that in more detail in a little bit here. A tool from NOAA called OpenInspect, that's really our sedimentation and pollutant modeling tool, and then some sort of a marine plume model, and I'll talk about what we did for that. And then MarkSand, so basically Vista characterizing scenarios coming into Inspect to model the land-based pollutants, a marine plume model taking those from the land base into the marine realm, bringing it back into Vista, and then MarkSand being used for prioritization. So that's our core ILSP toolkit, but we can hang other tools onto it according to what the particular issues are in the region that we're working in. So for example, when we worked in the Charleston, South Carolina region, that one was really mostly about coastal hazards. So there was a coastal hazard tool in there, but we can have things like Seasketch, which is a great online collaboration tool, Community Viz Land Use Planning, SlamView, which is marsh migration under sea level rise, Invest, which is a popular ecosystem service modeling tool. So there's a lot of different tools that can be hooked up to this. So let me just talk a little bit about Vista. So I mentioned it's an ArcGIS extension. It's been in release since 2004. We have an endowment, so that's allowed us to keep it updated. It's a very broadly capable tool. Generically, the objective of this is to integrate conservation with a lot of other different planning sorts of activities, and we've used it for a ton of different things. And then there's help for different skill levels, and we offer full support and so on for it. So in terms of the analytical process, we begin with this idea of what we call the conservation element. That's the thing that you're interested in assessing impacts upon it, as well as planning to retain a certain amount of representation of it within your planning region. So there's maps, there's expert knowledge parameters, there's stakeholder values embedded with it. One of the simpler analyses is a weighted overlay called a conservation value summary, but there's a lot of different options for it, but that's basically about exploring patterns of value based on your conservation elements. Then there's a process to characterize scenarios. There's both a physical component of what's going on in the land, air, and water, as well as a policy aspect of what's driving those things. And then you can have as many scenarios as you want. So we typically start off with our current actual situation, what we call a baseline scenario. And then we would have future trends, build-outs, climate change trends, invasive species trends, and so on. And what we're interested in doing, is doing a cumulative effects assessment. There's 2 different cumulative effects assessment models within the tool. And then it's going to generate a whole bunch of maps and reports that are explaining to us how did our elements do under that particular scenario that we evaluated, and did it meet its overall retention objectives that we assigned for it. We can then go in, and there's a tool within Vista called Site Explorer, and we can explore what's going on in particular areas, the elements in there, and the scenario components in there, and how those components are affecting the elements. From there, we can turn this into a planning tool. So I can do just an individual site mitigation. Say, well, I don't like the impacts at that site. Let me do something about the stressors in there. Or I can go site by site and create a whole new scenario. The human brain isn't set up very well to do that on a very efficient, systematic way across a big region. So we have a wizard that works with MarkSand, which is a popular optimization software out of University of Queensland that's used worldwide. So that's going to generate an efficient solution, spatial solution for us. We bring that into Vista. We can evaluate it. We can redesign the spatial configuration, do things like add better connectivity to it, and assign what do we want to have happen in each site, and what implementation mechanism do we want to use to do that. And then that becomes a scenario that we can then track implementation progress of it over time. And so then we enter the adaptive management cycle where Vista's very well set up for if we get any new piece of information. It could be a new map, a new piece of expert knowledge. It could be a new stressor like a pipeline project comes out. We can very quickly update data and reanalyze and understand how that affects our plan implementation. All right, so briefly about OpenInspect, non-point source erosion and comparison tool. There's a lot of different hydro models out there, and you could plug in your favorite one into this toolkit. We like this one because it's sort of on the same caliber of planning level as Vista and relatively easy to learn and use. But the basic idea there is to feed it a scenario that can come out of anywhere, but we can send the scenario out of Vista into there, and then it can model the runoff. Now, contrary to the NOAA diagram here, it doesn't give you that plume, which would be really nice if it did, but all of the values stop at the shoreline pixels. And then we moved on to how do we model that out into the seascape. And so, again, there's a lot of ways you can do this. I'm reading about people's creative ideas all the time. For this one, we took this Maris imagery that gave us some intensities of sedimentation out in these marine areas, and then those were digitized. And then we used the outputs from NSPEC to then model the expected concentrations in a very kind of coarse, brute force way out into the marine environment. But that then gave us our milligrams per liter expected sediment and nitrogen and phosphorus levels in that nearshore marine area. So getting back to Vista, this is one of those conservation value summaries, so a richness map of our conservation elements. Now, we built on a project we've been working on off and on with the Conservation Trust of Puerto Rico for about 12 years. So we have a really robust terrestrial Vista project there. So then we added 4 different marine elements. So we have a couple different coral densities and manatee in there. And then we can get into the scenario part of this. So we have our elements. Now we need to characterize scenarios. And so because it's a cumulative effects assessment, the scenario is a stack of layers because these are rasters. And so the tool combines things in the most efficient way on the same map. So this one, we've got the sediment plumes out there, and then we've got the land-based source of that sediment in different concentrations from NSPEC. And then we have here layering in what's going on in the land, so red, urban, yellow, some of these light green, agriculture, dark green that's the national forest there. And then we do the scenario evaluation. So that's where the tool will automatically combine our elements with the scenario and then do a lookup to these expert knowledge developed response models. And so this is one of the output maps. This is a synthesis map where we combine the results for all of the elements together. So the tan is where we have elements, but either they already met their goals, even if they had conflicts, or there's no conflict at all. Now, of course, that's the national forest, and so other than the roads shown within there, there weren't any conflicts in that area. Where we have pink to red is where we have elements that had conflicts. Basically, they did not meet their viability criteria according to the expert model. And the darker the color, the more elements overlapping that are in conflict. So it becomes a conflict hotspot map. You also get a quantitative report. There's a red light, yellow light, green light. It's just one green light down there of how close we came to meeting our goals. We had stiff goals here, 100%. Retain all of everything just to demo the system. And then for each element, it's basically telling us what's the starting area, what's the average condition. So that's part of the cumulative effects model, is a condition-based model. What's the average condition of it? What was our goal? What is expected to be viable, and what percentage of our goal is that? And then each element, you can see their hyperlinks. There's really detailed reports on each element with a lot of charts and statistics. All right, so we had our assessment of what's going on, where do we have problems, are we meeting our goals, not meeting our goals, and now we move into the mark-sand stage of this where we're doing this optimization, and again, I could do a whole long talk just about that, but Vista has a wizard because this is really a pretty expert tool, mark-sand. It's difficult to run. When you built a Vista project, you essentially have everything you need to already run mark-sand. So essentially what we want to get out of mark-sand is some data layers that are going to inform this efficient solution and inform what is the relative irreplaceability of any site towards meeting our goals. Meaning if I don't get that site and its irreplaceability score is 100%, I can't physically meet my goals. It's not possible. The more options it can find, the lower that irreplaceability score is. So I'm not showing the irreplaceability score map. This is called the best of runs map, and it's just a binary map. It's either in or out. So green is in our solution, red is not in our solution. What you can see here is we actually ran this simultaneously to meet our terrestrial biodiversity goals and our marine biodiversity goals. And so you can see the shoreline, so we have green areas spanning these. We're going to start to focus on this area that was selected over here. And what we can see, this is the condition model that came out of Vista. So this has to do not strictly, but primarily with the pollutants, the land-based pollutants coming off into these plumes. And so the darker that warm shade there, the more intense or higher the amount of the pollutants that are entering that area. When that's applied again through the viability models, in Vista, we can see these results. So for example, this is Manatee. These were just buffered point distributions, but we can see blue, viable, red, non-viable. And these are I think this is medium density coral, red, non-viable, blue, viable. So going back to Vista, we have our Site Explorer tool. So I can select these units here. I can see what elements fall within those units and how much is there. I can see compatible area off-site, on-site, incompatible area on-site, off-site, as well as my scenario components, what's physically mapped to be going on there in that location, as well as how are the elements responding to that. So we had selected, some of these sediment levels, and we can see that our marine elements are responding negatively to those. And so, if we had some in-marine stressor, like fishing going on there, we could propose taking the fishing out, putting in a marine protected area, for example. But we wanted to focus more on these land-based stressors for this demo. So again, we've got this area. We know that there was a lot of sediment appearing in there. We can trace upstream into the watershed. Might be a little hard for you to see, but there are these brown shades in here. That's from NSPEC showing the expected levels of milligrams per liter of sediment coming off of every pixel. So we can look for some of those more intense areas. We can highlight that. Again, I can see that level that's in there. I can see the response is negative. These are our terrestrial ecosystems. So they're responding negatively to the erosion that's happening there. So I can propose a change. So I just do a pull down on a list of available actions. Here I can select the erosion control. So what if I apply that to that area, and then it recalculates all of these statistics as well as the response. And if I like it, I can save that out into a shapefile, and I can incorporate that back into a scenario. But we want to close the loop, so we drew this polygon and we fed this back into OpenNSPEC, and we basically said we're going to do revegetation. So we tell it what land cover type we expect it to be put back into. Reran it, you can see that sediment has now disappeared from there. And then we carried this back into the marine plume model because we wanted to know, did we make enough difference there? And these look the same. Graphically because the scaling on it, but we actually reduced the amount of sediment in the plume by about 10%. Now, the next step, we could go into Vista and we can reanalyze, did that bring us over the threshold so we're now viable or not? because every element has a condition threshold. If not, we just repeat. Somebody said yesterday, wash, rinse, repeat, right? So we can choose some other areas and keep adding to that until we get to that place through iteration where we've met our objectives. All right, so that's it on the demo. So just some conclusions. So the workflow that I showed at the start, all the boxes and arrows, is going to guide that application of the tools. It's sort of like it's the map that tells the technical folks how to apply the toolkit in what order. The toolkit, like I mentioned, can be configured for the particular issues, management questions, and geography and capacity of the area. As Samantha showed, it's feasible for one person to learn this, but the intended use really is for a collaborating group of organizations. So if I'm the land use planner, I'm probably not going to learn Vista. I'm going to focus on my land use planning tool. If I'm the hydrologist, I'm going to be focused on that. For example, the inspect. So that's the idea that we're intending to use it. And so then the idea is that the toolkit can be used, to do the assessment, to develop the plan, but also again that ongoing plan implementation and adaptive management. So I'll stop there. I'll just leave up here for you some follow-up activities. You can download Vista for free, fact sheet in the back, and thank you very much.